Falcon Heavy by SpaceX has reached an incredible milestone. It surprised NASA scientists with its successful launch and deployment of a record-breaking payload into orbit. The rocket has left experts amazed. Scientists want to find out more about its advantages. SpaceX was founded by Elon Musk in 2002 with the aim of making space travel more affordable. The company has successfully advanced commercial spaceflight, including developing reusable rocket technologies. The Falcon Heavy is a key component of the SpaceX lineup. This is a heavy lift launch vehicle with partial reusability that can carry cargo into Earth's orbit and beyond. It combines 3 Falcon 9 cores, each equipped with 9 Merlin engines, resulting in a total of 27 engines. This vehicle generates more than 5 million pounds of thrust at liftoff, equivalent to about 18 Boeing 747 aircraft at full power. It was made to be the most powerful operational rocket in the world. The rocket stands 70 meters tall. It can lift 64 metric tons to low Earth orbit, or LEO. The vehicle is capable of carrying large payloads such as satellites and spacecraft. This is used for both commercial and governmental missions. The payload capabilities far exceed those of other rockets currently in operation, including the Delta IV Heavy, which is its closest competitor. It has the second highest payload capacity of any currently operational launch vehicle behind Space Launch System by NASA, and the 4th highest capacity of any rocket to reach orbit, leaving behind Energia and the Saturn V. SpaceX conducted its first launch on the 6th of February 2018 at 8:45 UTC. As a dummy payload, the rocket carried a Tesla Roadster with a mannequin dubbed Starman in the driver's seat. A year after the successful demo flight, SpaceX had signed 5 commercial contracts worth $500 to $750 million. This showed that it had managed to cover the development cost of the rocket. The second flight, and first commercial one, occurred on the 11th of April 2019. It launched Arabsat 6A, with all 3 boosters landing successfully for the first time. The third flight occurred on the 25th of June 2019, launching the STP-2, the DoD Space Test Program payload. It was composed of 25 small spacecraft. Operational Geostationary Transfer Orbit, or GTO, missions for Intelsat and Inmarsat, which were planned for late 2017, were moved to the Falcon 9 full-thrust rocket version, as it had become powerful enough to lift those heavy payloads in its expendable configuration. In June 2022, the U.S. Space Force certified Falcon Heavy for launching its top-secret satellites, with the first such launch being USSF-44, which happened on the 1st of November 2022, and the second of which being USSF-67, which was launched 11 weeks after USSF-44. Viasat selected the Falcon Heavy in late 2018 for the launch of its Viasat-3 satellite, which was scheduled to launch in the 2020 to 2022 timeframe. However, it did not launch until the 1st of May 2023. But the Heavy picked up the pace on July 28, 2023. It successfully launched the Jupiter 3 satellite into a geostationary transfer orbit. This is also known as EchoStar 24. The launch occurred at 11:04 p.m. Eastern Time from Kennedy Space Center's Launch Complex 39A in Florida. Jupiter 3 is the heaviest commercial communication satellite ever launched. It weighs over 9 metric tons and was built by Maxar Technologies. The satellite is designed to significantly enhance broadband capacity for Hughes network systems. It doubles the existing capacity of the Hughes Jupiter fleet with an additional 500 gigabits per second. Its 2 side boosters successfully returned to landing zones 1 and 2 at Cape Canaveral Space Force Station shortly after launch. Recently, on June 25, 2024, The GOES-U weather satellite was successfully launched from Launch Complex 39A at Kennedy Space Center in Florida. It was equipped with 27 Merlin engines. They generated 5.1 million pounds of thrust, propelling the rocket and its payload into space. GOES-U is the fourth and final satellite in the Geostationary Operational Environmental Satellite R series. These were built by Lockheed Martin for the National Oceanic and Atmospheric Administration, or NOAA. The spacecraft will be renamed GOES-19 once in geostationary orbit. It will undergo an orbit commissioning and then be moved to 75 degrees. Then it will take over from GOES-16 as the operational GOES East satellite. The mission has achieved several unexpected milestones, particularly regarding the deployment and capabilities. One significant achievement was the successful deployment of the compact Coronagraph 1. It's an instrument added somewhat last minute. This device will enhance NOAA's ability to study the sun's corona with greater frequency. It will provide advanced warnings of solar activity that could affect communication systems on Earth, power grids, and GPS accuracy. This addition is important for early detection and preparation for solar storms. These can be particularly harmful to technology and astronauts in space. Another notable success was the detection capabilities of the geostationary Lightning Mapper and the Advanced Baseline Imager on the GOES-U. These instruments are designed to provide detailed imaging of weather patterns and phenomena. Impressively, the ABI can detect fires as small as a barn fire from 22,000 miles above Earth. This is particularly beneficial for monitoring and responding to wildfires. These advancements reflect significant steps forward in both solar and Earth weather monitoring. The SpaceX Falcon Heavy launch faced several significant challenges. One of the primary hurdles was the weather, which posed a substantial risk to the launch. Initially, there was only a 30% chance of favorable conditions, but the launch window opened up just enough to proceed. Another technical challenge was the complex sequence of burns required for the second stage to place the GOES-U weather satellite into a geostationary transfer orbit. The stage had to perform 3 burns over a span of 4.5 hours to achieve the desired orbit. Additionally, managing the recovery of the boosters was a complex operation. The Falcon Heavy's side boosters had to perform synchronized landings, which required precise coordination and timing to ensure successful recovery at the designated landing zones. Despite these challenges, the launch was a success. This marked the first time NOAA launched a GOES weather satellite on a Falcon Heavy rocket, which also contributed to extending the satellite's operational life by optimizing fuel usage. NASA reacted positively to the successful launch. The agency highlighted the importance of the mission in enhancing weather forecasting and climate monitoring capabilities. John Gagosian, who is the director of NASA's Joint Agency Satellite Division, expressed pride in the successful collaboration between NASA and NOAA over the GOES-R program. He noted that the launch was a picture-perfect event and emphasized the satellite's role in providing critical data for severe weather tracking and climate studies. This mission also marks the completion of the 4-satellite GOES-R series, setting the stage for future advancements with the upcoming Geostationary Extended Observations, or GeoXO satellite system, scheduled for the early 2030s. Looking to the future, SpaceX has ambitious plans for the Falcon Heavy and other projects. One of the notable future missions is the Europa Clipper mission. It is scheduled for launch in October 2024. This mission will send a spacecraft to Jupiter's moon Europa to study its icy crust and subsurface ocean, which could potentially harbor life. Originally planned to launch in NASA's Space Launch System, the mission was reassigned to the Falcon Heavy due to delays and cost overruns with the SLS. SpaceX also continues its Starlink project. This is aimed at creating a global satellite internet constellation. Several launches are scheduled throughout 2024 to deploy more satellites. Another significant mission is the Arctic Satellite Broadband Mission, or ASBM. It is planned to launch in July 2024. This mission aims to provide broadband internet services to the Arctic region, enhancing connectivity in remote and underserved areas. Overall, Falcon Heavy and other launch vehicles are made to support a variety of missions. They will contribute to scientific discovery, global connectivity, and commercial space activities. That's all for now regarding the Falcon Heavy mission. This has once again shown SpaceX's skill in developing space technology. It set a high bar for future launches. What do you think the next big achievement in space will be? Share your thoughts in the comments below and subscribe for more updates.